how do you address building something which takes a huge amount of power?
So being very thoughtful. All of our standby power, for example, is fueled with hydrogenated vegetable oil, so a far more sustainable version of backup power. So you sort of democratise the availability of AI, then the more it will be consumed. Ironically, then the more data will be created, so the more infrastructure you'll need. So unless this goes on exponentially forever, we will have to innovate to improve the energy efficiency for compute power. There will be a sort of a significant movement away from the large language foundational models that we've already seen, which take the hundreds of megawatts of compute power to put together and to learn, into more distilled applications.
Dame Dawn Childs, pleasure to have you here.
Thank you.
So you're the CEO of Pure Data Centers. Could you give us an idea of what Pure do?
Pure Data Centers build and operate data centers for big tech customers, so what we call hyperscale data centers globally. And we do this in supply constrained, high demand, so where the customers want to be and where there are lots of data flows. But we also do it in a very ethical way where we worry about the communities in which we operate, and we also worry about the impact of our data centers, so think carbon footprint, think energy use.
Well, that touches on a point which I think is very important, the awareness of the climate. We all know there's a lot of controversy around that, but how do you address building something which takes a huge amount of power and apply that in a modern world where there are more and more challenges?
So being very thoughtful. So considering both the components of the data center, so the tools and the concrete, the asphalt, etc. So trying to find the most, or the least rather, carbon intense versions of those. And also thinking always about the type of energy we're using. So all of our standby power, for example, is fueled with hydrogenated vegetable oil, so a far more sustainable version of backup power. And we always try to get the most sustainable power sources available. Because we operate globally, that doesn't always mean it's solar or wind power. And of course, some of those renewable power sources aren't as reliable as they need to be. So it's always the best efforts that we can make, but we always try and also reach further into the community and worry about the footprint that we're leaving in the community in which we're operating. So we plant, for example, tiny forests. We've just planted a tiny forest in London near our data centre there to help the community impact. And we also do an awful lot of outreach in terms of learning and I think demystifying some of the data centre sector. So we try to be very thoughtful about what we do.
And I did see, if I'm correct, you created the largest living wall in the world.
Indeed. So our data centre in London is in a location where it's the only place in the UK where somebody had pollution as a cause of death on their death certificate. So the largest living wall that we're wrapping around our data centre will have the impact of taking thousands of cars off the road a year by absorbing pollution. It's going to have hundreds of plant species in there to try and enhance the biodiversity of the plants in that area. And as I say, helping to take pollution out of the atmosphere. So really worrying about what we're doing and the impact we're having on the community.
I think it is extremely thoughtful. It sounds like more like a science documentary. So another aspect, obviously our main subject is in and around artificial intelligence, and it's something that has blown up. It's changing the world very, very quickly. There's a huge amount of views, thoughts, opinions, directions, and it sounds like your customers are some of the most influential players in and around the space of AI. I don't suppose anyone knows what the next 3 to 5 years looks like. But one thing that I think we do know, it is going to exponentially grow. It is very, very important. It's going to touch upon society. It's going to touch all of our lives, most likely for the better in many, many ways. So we work with healthcare professionals, so from surgical AI, from research and development, from entertainment. AI is touching everything. Now, at the core of that is supported and very much dependent on data centers. So it puts what you're doing as a vital part of critical infrastructure. How have you experienced this crazy adoption of AI worldwide in the last couple of years?
And so the demand for data center capacity has significantly increased, but so has the data that was being used anyway. So a recent industry report described the amount of data that had or the increase in data over the last decade as 100 times. So even without this sort of thirst for AI, we were already significantly expanding. But importantly, the amount of power consumed to drive that data consumption and data processing has only increased by half. So it hasn't increased by 100 times over that period. So I think that there's an awful lot of work that will be done in the next coming years to try and decrease the power intensity of compute, so enabling more compute with less power, and that has been seen over the past decade anyway, just with normal data use, notwithstanding AI. I also think that there will be a sort of a significant movement away from the large language foundational models that we've already seen, which take the hundreds of megawatts of compute power to put together and to learn, into more distilled applications. So I think that we'll see the move that we've had over the past few years to these large scale campuses, these gigawatt data centers with significant compute power. Yes, of course, some of that will continue, but we'll also see a movement and increase in the edge, where the use cases and that really low latency requirement will come to the fore as more and more people have things that they want to have applications using AI. So I think there will be this continued transition. But suffice to say that the data center industry is working really hard, and Pure in particular is working hard at being considerate about building the data centers in the right locations, because there's quite a scramble at the moment where lots of sovereign powers and countries are declaring their desire for owning AI and making sure that they have sovereign capability. But we need to make sure that we can enable that, and we can enable it in a very thoughtful way and an enduring way. It needs to be sustainable. I don't want to be building any data centers that then become an unused tool in the future because the model has moved on. So yes, I think being very considerate about what we're doing.
It's interesting because there are some key points that you pushed upon there. So data, the idea that data is expanding, it's fluid. Also, that could look at knowledge. Knowledge is all the history books. To understand the future, there has to be a good comprehension of the past. There's more and more data being created because the mediums in which people operate and live, and even as you're talking about that, maybe small language models. Our thing is large geotemporal models, which is in effect a much more efficient version, but it's observational, so it's real time. And I think the adaptation of new foundational models, which will become distilled and refined out, is still connected, because observational AI is going to be extremely important. It still needs a mind, I think, to think through, which won't necessarily be device based. Devices will probably still be like we have connected units, like a mobile phone, that go through a network and still need that compute power. But the real-time element of data flowing on an expanded level, where, as you said, it's not all about training one huge model. We're already seeing that partially with DeepSeek, and then with other types of models. These models are becoming more efficient, So it becomes more accessible. And like everything in life, if you imagine the first mobile phones, I think the only person that had them was Dom Jolly for his TV show. Now everyone has them.
Indeed.
Even grandparents have them. All technology becomes so much more available. And to consider how that needs to have that infrastructure there to work, clearly this is an evolution of an underlying foundation which is going to be here for the next 50 to 100 years. Is there a comparative industry that you can think has become an institution that has formed the backbone of what is business society?
And so if you think back to electricity even, it was something that very few people had, and as they put the grid together, going back sort of close to 100 odd years now, it was in connecting a few people who had, few villages who had created their own generators and so on. And then all of a sudden, the more connected you became from an electrical perspective, then the more it was in people's homes, and the more domestic products were created, and then everybody had domestic appliances at home, and so more power is required. And as we go on, now we're getting to data centers, even more power is required. I think innovation was moved on and created to enable that and to enable the further electrification. If we think about data centers and data infrastructure as this fourth utility, I think it will have very much the same effect. The more you're able to make things available to people, then the more they will use it. The cheaper it becomes, the more they will use it. So you sort of democratize the availability of AI, then the more it will be consumed. Ironically, then the more data will be created, so the more infrastructure you'll need. So unless this goes on exponentially forever, we will have to innovate to improve the energy efficiency for compute power. We will have to innovate to enable the current electrical grids, particularly in UK and Europe, to facilitate and enable the connected future that people desire. One of the bizarre things that I heard recently was that we're sort of running out of human-generated data, and we're getting to the tipping point now where there's more computer-generated data than there was human-generated data. So we need to be thoughtful about the ethics associated with this. To pick up on your brilliant point of learning from the past, we need to make sure that we're learning the right things, and we're not learning something that has been hallucinated or conceived by AI itself, rather than by actual thinking and due process and knowledge.
But there's another spin to that as well. I mean, one of the things we've become aware of, in order to achieve the level of accuracy of results in some medical research, it's just not possible to have enough of a certain type of data. So in fact, you can accurately create masses of synthetic data. So for an ethical cause with a very particular goal, which obviously requires more compute power, but it is entirely possible to synthetically create to human benefit.
Yeah,
and
completely.
The other element was education. So we've had Professor Sharples, an incredible man. He was doing generative AI in 1978, one of the main guys at the Open University, incredible man. Various professors and numerous individuals who hold education and the future of education at their heart. And the common theme that we've heard is pulling together what we know to be fantastic thinkers, great educators, both living and of the past, learning how they communicated, how they solved problems, and empowering school children to grow up with perspectives, views, and access to education, which otherwise wouldn't be possible. I mean, I would love to have Richard Feynman. I mean, one of the guests we've got coming on was quite literally taught in lectures by Richard Feynman. I think he's one of the most incredible people ever to have lived. His humour, his wit, his how he observed the world. And obviously it made a big difference with his contribution to, I believe, the Manhattan Project as well. which changed the course of history. But if you could imagine having him get to know you from a child, and you can effectively communicate, learn, chat, become a friend with, and see a different perspective, but perhaps also it could be Marie Curie, it could be anyone, that as a real-time, constantly building data model, and people who would never have the economic circumstances, or are too far away, or just wouldn't have access to it. And you could be talking about kids across Africa who never got the chance. Could be impoverished areas of the UK, even. It could be even for privileged people, for everyone. And that as a backbone to be able to support that, and obviously that's going to create vast amounts of data, but with greater efficiency, that is going to be needed to be supported. So it's better to have long-term ethical thinking around that, because the impact this journey can have, I think, is going to go far deeper and be far more compelling than I think is ever reported.
Completely, and I think it's just important to enable that sort of bleeding edge of critical thinking to continue, but always considering the ethics, and you're not stifling innovation, not stopping it, because there is the potential, if we don't have all of industry working together, working with governments, working with utility providers, working with communities. At Pure, we try to lace together the collaboration that's needed, because I like to think about this challenge of building out data center capacity to meet this fantastic aspirational future of the connected lives that everybody could lead, the amazing innovations that could be driven through that access to knowledge and the use of AI. I like to think that we drive that collaboration, and I consider the challenge of meeting this exponential demand for AI and for power as a bit of a wicked problem. And there are only three pathways out of a wicked problem. One is regulation, i.e. stop it. One is competition, so it effectively stops itself. The other is collaboration. This is such a big challenge, and it's a world-changing challenge. We all need to work together on it. And I think that there is a great future where if we continue to work together, we continue to think about the ethics, think about the best way to move forward and make it sustainable and enduring, then we will absolutely find a solution to the problem. And my team at Pure are thinking about this every day, worrying about how we can minimize the impact of our data centers, but still maximize the delivery to meet that demand from big tech to create that fantastically aspirational future.
Now, just from a different angle, different perspective, you as an individual and your background coming into this, how did you find a passion to being where you are today with this?
It's a very strange story. It's one of those where if somebody stops and asks for directions, the person might say, well, I wouldn't start from here. That was slightly my career. I joined the military straight from school, was sponsored through university, and had every intention of staying in the Air Force. But for various reasons, I decided to leave to try and maximise my career, and then went through Gatwick Airport, Merlin Entertainment, so theme parks, and then National Grid. And I was then called up by a headhunter looking to recruit an ops director for Pure data centers. My first question was, what's a data center? I didn't, being an engineer my whole career, I knew what a server room was. I didn't actually know what a data center was. I hadn't stopped to think, where does the cloud actually live? Where does the internet live? And it's in data centers. And so once it had been described to me, and I'd spoken with the founder of the company, and he sort of said, no, I need somebody who's got sort of critical infrastructure background. I need an engineer. I need somebody who's an operator. And when I pieced it all together, I thought, gosh, actually my very strange career path is perfect for data centers. And so once in the industry, I quickly gained a passion, because it is it is the future, that there is so much that can be done through data centers, and I think it's really important to try and lean into this very fast-paced industry, and absolutely pick up a paddle and start paddling to help.
And what are the biggest problems that you've had to solve with the data centers that you've been involved in building across the world?
So the first data centers that we built for Pure was through COVID. So that in itself created some challenges, particularly building a data center out in Indonesia. That was, building in London was hard enough in COVID, but in Indonesia was a whole different story. So some of those challenges which everybody endured along the way. But I think one of the biggest problems that Pure we've tried to solve is going into constrained markets. So where you already have a cluster of data centers, and a particular big tech company already has some data centers in a particular region, they look to expand in that region because it makes sense to have the failover capability and to make the best use of the infrastructure they've already embedded, so it's more sustainable actually, rather than creating a new network node somewhere else. So we look to try and unlock some of those challenges. So being very careful about site selection, finding the right sites, unlocking some of the power challenges, because several European countries have moratoriums in terms of data center connections. Here in the UK, we don't have a moratorium, but if I put in an application for power for a data center in London now, my connection date would be more than a decade away, which clearly, given what we just described about the demand for data centers, will not be acceptable. So trying to unlock and enable some of the power to be found, so we can build the data centers in the locations where they're needed and wanted, and we worked very hard to do that.
And what would you hope that the future can bring with how people look at power grids, both starting in the UK, then internationally? Because it's something I imagine a lot of people are not really aware of, and it would be fascinating to give people some context to discover the fundamental requirement for a data center. It requires power.
It does, and so we're talking in the sort of tens or hundreds of megawatts, depending on where you're building the data center and who for. And at the moment, those sort of power, that sort of power availability, it's not necessarily the generation that's not there. The generation is probably there. It's the transmission that's the challenge. So particularly here in the UK and in some other European countries as well, the power being generated is sufficient. It's just not getting to the right location, because we have quite aging infrastructure and it's been built up over decades. So I think that data centers, rather than being seen as part of the problem, particularly as we think about the green transition and enabling more renewable power to come onto the grid, I think we could really be part of the solution, even with the data center infrastructure we already have. Because think about some of the challenges that we're seeing over the last few weeks with fires in substations and power going out at at Heathrow Airport, for example. Every single data center has the same amount of power in backup generation as it draws from the grid. And so that backup generation could be used to help to enable some of the green transition without some of the other larger generation and transmission infrastructure being built. Part of the problem that is seen, though, is the balance of the grid. So at any one moment, the power being drawn from the grid must be the same as the power going into the grid. And if you think about renewable energy, so think solar, think wind, the sun isn't always shining and the wind isn't always blowing. But when it is sunny and windy, there's an excess or a surfeit of power that's being generated. So creating some way to store that power, we have very good large-scale batteries on most data center sites as well. So you need somewhere to store the power. You also then need some other generation to come online when it's not windy and it's not sunny. So having some of these smaller sort of sections of tens of megawatts of power available at certain positions on the grid might be very helpful to avoid having to wait for the entire problem to be solved with all the transmission in place and new generators in place. So I think working with the grids to try and help to unlock some of that problem is something that Pure's trying to do.
Well, I saw that Tesla had, I think it's the Grok model. One of the methods they had was ensuring consistent power from obviously batteries originating from the grid through, for training a model, and that it was beginning to be understood that a direct fluctuation can cause erroneous data within the model training. So actually the importance of accuracy and authenticity of information at its actual creation is actually tied to these little nuances which most people wouldn't consider, but are critical. So it's fascinating to hear that there's some science to, power coming in, power coming out. I believe also there's power imported from places, and we export power.
Yes, there's interconnectors. So think if it was water, think large hose pipes, but it's power. So large cables, subsea cables, and connecting various parts of the UK to other parts of the UK to ensure that things like the wind power being generated up north can has a swift pathway down to major users down in the south and so on. So yes, so there are interconnectors, and more interconnectors being put in at all times, both intercontinentally as well as, say, around the UK.
So you're telling me earlier about biochar. So
Indeed,
please elaborate and share with the viewers what you did there.
It might seem strange for a data center company to be thinking about biochar, but as we have an R&D department called Healthier Earth, which really focuses on how we can decarbonize our data centers and how we can work better with the community to make data centers sit well, as part of critical national infrastructure, but also as a good neighbour. And biochar was one of these things that we were sort of thinking about and working with. And for those people who don't know, which I would imagine many people don't, effectively you take organic matter and rather than burning it, you pyrolyze it. So effectively burning it in the absence of oxygen. And in doing that, it sequesters, so it captures a significant amount of carbon because it turns into a kind of powder and has a very large surface area. So that becomes like a peat type material. So it can be used for multiple things, one of which is as a substitute for peat, and it helps to create far more productive plantings. So we were the biochar partner at COP28 out in Dubai, and we were showing how good biochar was as a growing medium to create more productive plants, but also to move towards de-desertification, so creating far more productive soil. We're also using it, or will be using it, in our living wall in our data centre in London to make better use of water. So it significantly reduces the amount of water because it retains water. So it reduces the amount of water that you would need to irrigate planted materials. It can also be used for urban adaptation. So we're doing trials of it in asphalt to better absorb water, but also to sequester carbon. So if you think in the local communities that we're working with in the London area around our data centres, we're looking at trials of using biochar infused pieces of infrastructure to help to absorb floodwaters and the like. So it can be used greatly in urban adaptation. And I think all of these sort of sidekicks that come out of one thing that you were trying to focus on to try and make data centres more sustainable and to make data centres better for the local communities has multiple uses. So we're actually in process of building Europe's largest biochar production facility here in the UK.
That does sound extremely fascinating. I mean, so many great ideas are a byproduct of something else. I mean, even PayPal, the original company, that wasn't what it was, and they just added a little feature, I believe, which was, well, imagine we could just send money by email on top of everything else. And then in the end, the rest was scrapped, and that was the one thing that became the big idea that worked. But even looking at from the climate perspective, urbanization, I mean, I know in Spain there's a lot of desertification and social change, which is driving younger generations towards the cities. And again, you could look at that and say that's because of social media adoption, the awareness. People don't want to be necessarily farmers in more and more arid land. So there are cultural shifts. Technology is definitely playing its part, not necessarily for the better, but technology could equally help solve a lot of those problems, because at the end of the day, everybody in the world needs to eat, and that requires some fundamentals, which is the ability to grow food. And so much of the world is suffering from lack of nutrients in the ground. I mean, you've just, from my mind, talked about 9 different problems being solved with one particular thing, which I think anybody from anywhere in the world could relate to some of them and see the value and the importance.
And I think that links in to another aspect for data centres working with local communities, which again through our R&D arm led us to a different thought trail. So heat reuse. So a data centre, because servers run very hot, we have a significant amount of cooling infrastructure that takes the heat away. So you end up with excess heat that could be reused. So sometimes that can be linked into a local heat network and help to heat some homes. So people get free heat in their houses, which is great. In other places, it could be used to link into a vertical farming setup. And it was because we were thinking about the heat reuse for the data centres and vertical farming and creating potentially a model where we not only built the data centre but also built the vertical farm. We were then looking at, well, what's the high value food that you can put in the vertical farm, and what's the best food that can be grown at the temperature of the offtake heat that we have. And we realised that actually growing the food in the vertical farm wasn't the most helpful thing to do. So we then started a trial of trees in a vertical farm. And so we have what we now call a forest factory. In fact, we have one in place at Blenheim Palace, where we're helping to grow their ancient oaks, because even though as part of people's efforts to create carbon credits and sequester carbon, they're planting trees, you hear a lot about planting trees, the survivability of those trees wasn't great. And so in the vertical farming forest factory system that we've set up, we use our biochar, which obviously is helpful in some of them when we plant them out. But the survivability, because of the detail that you can put into the lighting, the amount of nutrients they get, the irrigation they get, and so on, you create a far more sturdy tree with a better root ball. And so the survivability has gone up nearly 100% of these saplings that are being planted out. So all of these spin-offs just come from critical thinking by Pure's team and our R&D team, A Healthier Earth, in trying to solve problems. That's all we need to do, solve problems.
It wouldn't surprise me if that forms some of the foundation for growing organic matter in space.
You never know.
Inevitably, at some time soon, there will be the need or the desire, shall we say, to be growing things in orbit and outside the world. And the ideas for how things are done is usually through solving fundamental problems. The reapplication of solving problems in different contexts in different countries or areas, remits, is what the world is made of. So, Dame Dawn Childs, thank you very much. It's been a pleasure.
Thank you so much.
Excellent.